Consider consuming a parallel or asynchronous library that doesn't expose the asynchronous operations using the task parallel library, meaning that it doesn't provide you with a task, but it has an alternative way to let you subscribe to when it's done. This could be allowing you to subscribe to an event that indicates when the operation completed. One example of this is the event-based asynchronous pattern, used with, for instance, the background worker. In the early days of the background worker, the only way for you to know that all the data was loaded was to listen for an event. It could also be used where you're manually scheduling work on the thread pool, and that thread wants to communicate the result back to whoever's listening. This is where we introduce the task completion source. This creates a task which could be returned or awaited. The task completion source is then used to indicate that the task has a new result. Let's jump into the exercise files. The search click method, it's awaiting a call to search for stocks, and I've made some changes to search for stocks. Instead of using the task parallel library together with the async and await keywords, this method now queues work onto the thread pool. It's also loading a cached file from disk instead of querying the API. You'll see that there are compilation errors and some other problems that we need to fix. The method needs to return a representation of the asynchronous work. We need a way to grab the result from the thread that loads the file. Only after that is done, we want to populate the UI. Loading the file like this is similar to when we used task.run. But when we queue the work onto the thread pool, we can't await that. We need to introduce the task completion source to help us with this. The task completion source is generic and allows you to specify what type of result that you're expecting to produce on the task when the operation completes. We're going to set this to an IEnumerable of stock price, as this is what is produced by the queued work. When you create an instance of the task completion source, you specify the task creation options. It's best practice to use the task creation option that determines that you're going to run the continuation asynchronously. You can experiment with that on your own and see how different task creation options behaves. With the task completion source added, how does this fit into the picture? How can we now use this to allow others to consume our work using the async and await keywords? Most important of all, how do we communicate a result from this queued work, which will then be set on the task produced by the task completion source? The task completion source exposes methods. For example, we can set a result. It allows to provide a way to get the task that represents the asynchronous operation. This task isn't running the actual queued work that we've added to the thread pool. It's simply a task that is only marked as completed when it gets a result set on it. This means the task produced by the task completion source can be awaited somewhere else. If you retrieve the task from the task completion source, it will give you the task of an IEnumerable of stock price. Our method can now return the task produced by the task completion source. We can call this from search click. We will then have a task of an IEnumerable of stock price. Await this, and you'll get the IEnumerable of stock price, which in the continuation can be added to the UI. We've now removed a few problems and the compilation errors. What's left now is to set the result on the task and for it to be marked as completed. This should be done when the work has finished on the thread pool. This is when we tell the task completion source that we have a result. We could also set an exception or a cancellation. Now you've communicated to the task that it should be marked as completed and that it has a result available. Whoever is now awaiting this will be able to retrieve the result, and it won't proceed to the continuation unless we have a result from the task completion source. It's now loading the file from disk and processing that, then uses the task completion source to indicate that it has a result. The file is being loaded using the non-asynchronous methods, but doing that on a separate thread because we queued the work on the thread pool. Let's run the application and make sure that it works. And will you look at that? It worked just as well as it did before. This shows you that you can use the task completion source to introduce ways of working with background threads or even event-based asynchronous patterns, but consume that like the tasks that we've come to really like.